Welcome back, everyone. For today's deep dive, we're looking at something pretty surprising that happens to astronauts. They actually get taller in space.
Yeah, taller.
We're using excerpts from astronauts, taller in space, back on Earth, to guide us. Our goal here is to really unpack how this happens, this physiological change, and, what it means. So let's just jump right in. How on Earth, or maybe off Earth, does someone get taller just by going into space?
Well, it's fascinating, really. It boils down to microgravity, that near weightless feeling in orbit.
Right, the floating.
Exactly. So without Earth's gravity constantly pulling down, your spine, well, it stretches out.
The whole spine, like the bones grow.
Not quite the bones themselves. It's more about the bits between the bones, the vertebrae. There are these cushiony discs filled with fluid.
The intervertebral discs, shock absorbers.
Precisely. On Earth, gravity squashes them down, compresses them. In space, without that constant compression, they can sort of plump up. They decompress and expand because more fluid shifts into them.
Okay, so it's the discs expanding, not the actual vertebrae getting longer. That's a key difference.
It is.
So how much taller are we talking? Is it, noticeable or just a tiny bit?
Oh, it's noticeable. Astronauts can gain anywhere from, say, 1 to 2 inches. That's about 2 to 5 centimeters. It varies a bit person to person, mission length.
1 to 2 inches. Wow. Okay. But you said it's temporary.
Absolutely temporary. As soon as they're back on Earth, gravity gets to work again. It starts recompressing the spine almost immediately.
So they shrink back down.
They do. Usually takes just a few days for the fluid to redistribute and the discs to go back to their normal size, back to their pre-flight height.
You mentioned implications earlier. If someone's suddenly, potentially 2 inches taller, even for a while, that's got to matter, right?
Yeah.
For planning missions, designing gear, it's not just a fun fact.
Oh, absolutely not just a fun fact. It's a serious consideration for NASA, ESA, all the space agencies.
Yeah.
They have to factor this height change into equipment design.
Like spacesuits.
Exactly. Think about it. A spacesuit needs to fit perfectly. If it's snug on Earth, it could become dangerously tight in space if the astronaut's torso lengthens.
How so? What could happen?
Well, a tight fit could restrict movement, maybe pull awkwardly at the joints. Even the helmet alignment could be thrown off, which impacts vision. During a spacewalk, an EVA, you really don't want issues with mobility or visibility.
Yeah, definitely not.
And it's not just suits. It's gloves, boots, fitting into foot restraints, even how controls are positioned inside the spacecraft. Everything is designed with such precision, so unexpected changes in body dimension matter a lot.
So it's a real safety and operational issue, not just about being comfortable.
Correct. Safety is paramount.
Okay, so they grow, things might not fit right. What about coming back? When the spine squashes back down quickly, does that